Hey everyone, welcome back to Cruise class. In today's lesson, we'll be looking at a statistics topic known as the standard normal probability distribution. Now, just get this away. Now, the standard normal probability distribution. There are a few things we need to understand first when speaking about this type of probability distribution. Now, the first thing, the bell-shaped curve. We need to appreciate that it follows a bell-shaped curve, or the bell curve, some may call it. Secondly, it is symmetrical about the mean. So the bell curve is symmetrical about the mean. It's symmetric about the middle of the curve, or at the peak of the curve, it's symmetric. Third, the random variable has a mean of 0 and a variance and standard deviation of 1. Fourth, the random variable is called the z-score, or it can also be called the standard score. The total area would be equal to the total probability, which would be 1. So therefore, the total area under the bell curve would be equal to the total probability of that curve, which would be a probability of 1. Total probability is always equal to 1. Now, to calculate the z-score, we have z equal to x minus mu divided by what we have here would be sigma. That's what they call it. Alright, it's a Greek letter. Now, x is the individual observation, mu is the mean, and sigma is the standard deviation. So it would be the z-score equal to the observation minus the mean divided by the standard deviation. Now, after we work out the z-score, we can then use that information on the bell curve here, which would be the normal distribution curve, or the standard normal distribution curve. Now, points to note about this curve: the middle is represented by the mean, which is 0, and as we can see, the z-score to the left would be negative, the z-score to the right would be positive, and it is symmetric about the mean, meaning that even though this is not drawn to scale right now, because I'm a horrible artist, what happens is that the same area over on the left side is the same area on the right side, and as we can see, the area on the left is 0.5, the area on the right is 0.5. So both of these will add to a total of 1. So that is why we said the total probability is the same thing as the total area under the bell curve. So this is the standard normal curve, and this is an introduction to standard normal probability distribution. We can use this principle to solve for different probabilities for any random variable that coincides with the standard normal distribution.